Right now, you're watching factory workers manufacture Toyota's reliable 2.4 and 2.5-liter engines. Here inside Toyota Motor Manufacturing, West Virginia, 2,070 employees are working on engines and transmissions. This assembly line worker's name is Scott. On the main assembly line at Toyota Motor Manufacturing, West Virginia, employees earn an average of approximately $25 an hour. When running at full capacity, the plant produces a transmission every 25 seconds and a 4-cylinder engine every 30 seconds. Among the quickest production speeds Toyota achieves worldwide. These engines are widely considered reliable in everyday use, often lasting 200,000 plus miles with good maintenance. Many owners report long service lives in vehicles like the Toyota RAV4 and Camry. Some earlier versions, especially older 2.5 designs, had oil consumption, misfires, or cooling system complaints depending on model year. This is only Toyota plant in North America that builds both engines and transmissions under one roof. The plant was the first Toyota facility outside Japan to produce 10 million powertrain units. This is also the only Toyota facility in North America that produces hybrid transaxles, a crucial part for hybrid models like the Sienna and Highlander. In the process you're viewing now, factory workers and robots operate in close coordination. Programmable robotic arms move and install smaller components, while workers are responsible for final assembly and enclosing the engine. Inside this West Virginia factory, employees must follow strict safety dress codes and policies. Toyota manufacturing plants in the U.S. are not currently unionized by the UAW. Toyota historically has not had UAW representation at most of its U.S. factories, and workers at Toyota facilities are generally non-union employees. There's no broad current recall specifically targeting the 2.5-liter engines for catastrophic failure in the U.S. Most recent major recalls have involved other engines. Right now, you're watching a senior quality control technician inspect the finished engines using a standardized checklist. Once approved, the engines are transported to the main warehouse by forklift. The 2.4-liter turbo engine powers the Camry, Toyota RAV4, and Lexus NX. The 2.5-liter gasoline engine is used in the Camry, RAV4, Corolla, Corolla Cross, Lexus ES, and Lexus NX. From the control center, operators oversee the entire factory and monitor the full manufacturing process. The manufacturing process of each engine is, above all, a logistical challenge. Every component must be in the right place at a precisely scheduled time. The supply chain is critical to keeping this massive operation running smoothly. Inside this Toyota factory, women have historically made up a significant minority of the workforce, around 30% of manufacturing employees. Toyota also highlights women in leadership and skilled roles at its West Virginia facility, including team members recognized for excellence in manufacturing. Each workstation consists of several workers working together as a coordinated team. Every station has a supervisor responsible for quality. This Toyota engine contains roughly 2,000 to 2,500 parts, if you include every bolt, washer, and sensor. If you count only the main mechanical components, the total is closer to 500 to 800 parts. Last year, Toyota, including Lexus, sold about 2.3 million vehicles in the United States. That ranked near the top of the market, just behind General Motors and roughly on par with Ford. But now we'll move from Toyota's U.S. factory to the Descherd powertrain assembly, where V8 Titan engines for Nissan vehicles are produced. Since 1913 and Henry Ford's concept of automobile production, not much has changed. The core idea of the assembly line is division of labor. Instead of one worker building an entire product from start to finish, The work is broken down into small, repetitive tasks, with each worker or machine responsible for a single step. Parts move sequentially along a conveyor system, allowing products to be assembled faster and more efficiently. The plant occupies hundreds of acres, with over 1.1 million square feet of covered production space, making it one of the company's largest manufacturing complexes. It provides the engine and powertrain backbone for many US-built Nissan and Infiniti vehicles, supplying 4, 6, and 8-cylinder engines, as well as electric motors for select models. The facility is capable of producing up to 950,000 engines each year, along with 1.1 million crankshaft forgings, while managing critical processes such as casting, forging, machining, assembly, and testing of engine blocks, crankshafts, and other components. By combining casting, forging, machining, assembly, and testing under one roof, Decherd reduces logistics complexity and enhances quality control. Decherd remains the sole US-based engine production site for Nissan, with every US-built Nissan vehicle using a gasoline engine relying heavily on this plant. Unlike many engine factories, Decherd performs comprehensive hot fire testing, where engines are filled with fluids, connected to stationary dynamometers, and run under load to verify compression, timing, noise, vibration, and emissions. Kokomo, Indiana, is one of Stellantis' most important powertrain hubs in North America, forming a key part of the company's engine, transmission, casting, and machining network in the US. The Kokomo engine plant was created by repurposing what had been an idled transmission facility to produce the 2.0-liter turbocharged inline-4 engine. This engine is part of Stellantis' global medium engine family and powers vehicles such as the Jeep Wrangler and Jeep Cherokee, bringing US-based production for this unit that had previously been built abroad. Kokomo is home to multiple Stellantis powertrain facilities, including transmission plants, a casting plant, and the engine plant itself. Together, these sites produce a wide range of components like transmissions, engine blocks, and cast aluminum parts for both engines and driveline systems. While this isn't the engine plant itself, the Kokomo casting plant nearby has a long history and is globally notable for manufacturing aluminum castings for engines and transmissions. It is one of the largest die-casting facilities in the world, and the only plant in Stellantis' global footprint that casts components for both engines and transmissions. The Kokomo powertrain complex is not static. It continues to evolve with investments in new engine production, electrified drivetrain components, and manufacturing technologies to meet changing automotive market demands. The process often begins in the nearby Kokomo casting plant, which produces aluminum and other metal castings for engines and transmissions. Engine blocks, cylinder heads, and other key components are cast using high-pressure die casting and precision molds. Once cast or forged, the components are machined to exact specifications. CNC machines are used to mill, drill, bore, and finish the parts with extremely tight tolerances. After machining, parts are cleaned, inspected, and moved to sub-assembly areas. Engine sub-assemblies may include cylinder heads, camshafts, valve train components, and oil pumps. At the Kokomo engine plant, all sub-assemblies are brought together for final engine or transmission assembly. Workers and automated systems install pistons, crankshafts, cylinder heads, valve trains, and ancillary components. For modern powertrains, this can include turbochargers, variable valve timing systems, and even electric motor components for hybrid or electrified units. After assembly, every engine or transmission undergoes rigorous testing. For engines, this includes hot fire testing, where the engine is filled with fluids, mounted on a dynamometer, and run under load to verify compression, torque, timing, and vibration. Transmission units are similarly tested for smooth shifting, gear engagement, and durability. These tests ensure each unit meets Stellantis' performance and reliability standards. Once a powertrain passes quality control, it is packaged and shipped to vehicle assembly plants, such as Jefferson North Assembly, Toledo, or other U.S. Stellantis assembly locations. Kokomo's integration of casting, machining, assembly, and testing within a local complex reduces transportation time and ensures rapid delivery. The Kokomo powertrain operations aren't just one building. They're a set of interconnected facilities that together form one of Stellantis' most important engine, transmission, and powertrain manufacturing hubs in the U.S. This network includes the Kokomo engine plant, Kokomo transmission plant, Kokomo casting plant, and related machining and assembly operations. The Kokomo transmission plant has a long history of output and has produced millions of transmissions over its lifetime. For example, the plant produced its 1 millionth 8-speed automatic transmission for vehicles like the Jeep Grand Cherokee, Dodge Charger, and Ram 1500. The Kokomo casting plant plays a critical role by producing engine block castings, transmission cases, and other aluminum components that are used throughout Stellantis' powertrain manufacturing network. It has been operating for decades and remains the only casting facility in Stellantis' global footprint that supplies parts for both engines and transmissions. Earlier, Stellantis statements also noted that the company has more than 7,000 employees in Indiana across its operations, including Kokomo and nearby locations. With many of those jobs in casting, machining, and assembly roles directly tied to powertrain production. According to local economic data, Stellantis operates 5 powertrain facilities there, including the engine plant, casting plant, and several transmission plants, and together, these facilities employ around 6,600 people. The transmissions are now complete. A worker inspects them and stores them in the main warehouse. From there, they will be transported to the main assembly line at a predetermined time. So, welcome inside the Tonawanda Propulsion Systems plant. This is where engines are assembled for vehicles such as the Chevrolet Silverado, Corvette, Sierra, Suburban, and Cadillac Escalade. This experienced factory worker is assembling General Motors' latest 5th-generation small-block V8 engine. Inside the factory, employees make around $40 per hour on average. Much of the final assembly of these V8 engines is performed by hand, with skilled technicians using pneumatic torque wrenches. Since beginning operations, this factory has produced an incredible 75 million engines for General Motors vehicles. Because of the huge number of engines produced, occasional recalls or service bulletins do occur, but engine-specific recalls are relatively rare. The very first small block, a 265 cubic inch V8, debuted in the Chevrolet Bel Air. The simple pushrod design made the engine durable, low profile, and capable of producing strong torque. The GM small block is the longest continuously produced V8 engine family in history. Since its introduction in 1955, more than 100 million small block V8s have been built. Compact, powerful, and affordable, it quickly earned the reputation as the engine that changed everything in American performance cars. Its compact size and light weight made it easy to fit in nearly any vehicle, from cars and trucks to race cars. Right now, you're watching the finished engines being moved to the main assembly line, where they will be installed onto the vehicle's chassis. Throughout the factory, All engines are moved either on these conveyor belts or by automated guided vehicles. Transfers between workstations are closely monitored, and every step must be precisely coordinated. The process you're watching now is called the marriage. This is the moment when the heart of the car, its engine and transmission, is joined with the body, creating a fully functioning, road-ready vehicle. Once completed, the vehicle continues down the assembly line for the installation of interior, exterior panels, electronics, and final quality checks. This step is critical as it forms the backbone of the car and ensures everything is properly aligned for performance, safety, and durability. But now you're watching powertrain production in Romulus, Michigan, where the renowned HFV6 engine is built. Producing both a modern V6 family and advanced 10-speed transmissions under one roof allows GM to integrate powertrain manufacturing more tightly and respond to demand shifts in both engines and transmissions. It produces the 10-speed automatic transmissions used in vehicles like the Chevrolet Silverado, GMC Sierra, Cadillac Escalade, Chevrolet Tahoe, and GMC Yukon. The 10-speed transmission is a key component for full-size trucks and SUVs, helping with performance, efficiency, and competitiveness in a demanding market. Certain early versions were subject to timing chain wear and cam phaser issues in specific conditions, such as extended oil change intervals or heavy-duty use. The HFV6 engine lineup gives GM flexible powertrain options for mid-size vehicles and luxury brands. This is Saginaw Metal Casting Operations, a long-standing GM foundry with a history dating back to 1919. The casting process typically begins with molding, which can involve green sand, dry sand, semi-permanent molds, or permanent steel molds. Once the mold is prepared, molten aluminum is poured into the mold spout. This facility produces engine blocks and cylinder heads using both precision sand and semi-permanent mold casting techniques. It plays a critical role in supporting GM's engine plants, supplying aluminum heads for engines such as the 3.6-liter. For precision applications, such as lost foam casting, a foam pattern is used that vaporizes when exposed to the molten aluminum. The metal flows downward through runners and gates toward the head deck surface, filling the mold cavity to create the desired shape. The aluminum takes the place of the pattern, producing highly accurate, detailed castings that meet the demanding standards required for modern engines. This combination of advanced casting methods and skilled craftsmanship ensures that each engine component meets GM's strict quality and durability requirements. In the assembly plant, the engine block is first machined to exact tolerances. Pistons, crankshafts, and camshafts are installed with meticulous attention to detail. Cylinder heads are mounted, and components like fuel injectors, valve covers, and timing chains are carefully fitted. This is the assembly of the Chevrolet Corvette 6.2-liter V8 engine. When it debuted in the 2009 Corvette ZR1, the LS9's 638 horsepower made it the most powerful production engine GM had ever built. Each LS9 was hand-built at GM's Performance Build Center, originally in Wixom, Michigan, and later moved to Bowling Green, Kentucky. A single technician assembled each engine, and many units feature a signature plaque on the valve cover, a personal touch highlighting the craftsmanship behind every build. Unlike most LS engines, the LS9 employs a dry sump lubrication system, typically reserved for race cars, ensuring consistent oil flow even under extreme cornering on the track. The assembly process begins with a lightweight 319 T5 aluminum engine block. It is meticulously cleaned, inspected, and machined, with 6-bolt main bearing caps and cast-in iron cylinder liners added for strength and durability under high boost pressures. Forged aluminum pistons and titanium connecting rods, components usually found only in exotic sports cars, are carefully balanced and installed into each cylinder. Piston ring gaps are individually measured and precisely adjusted to ensure optimal performance and reliability. A hydraulic roller camshaft is installed and tuned for both track-ready performance and smooth street drivability. The timing chain, tensioner, and gears are fitted with precision to guarantee perfect engine timing. Rocker arms, push rods, and lifters are installed with exacting preload settings, with every component torqued and checked for proper clearance. The drive system and seals are carefully aligned to handle the high boost pressure, completing the LS9's high-performance architecture. Finally, the assembly concludes with the placement of the builder's nameplate, a symbol of the pride and precision that goes into each LS9 engine.
beim C-Klasse-Motor?
Nee.
gleich rüber.